I'd like to thank you, Mr. Seraphin, for holding this meeting despite all the problems we had through email. And after about a month worth of communicating back and forth, we finally set up a time. While also balancing the load of trying to achieve a degree in electrical engineering, I've invented a system that can protect America's electrical power grid and even the entire world's power grid if we have communication assurances. Now we're going to the second part. I simply covered the delivery methods. Now I'm moving on to the effective power. And after that, we'll cover the effects of that. So the first one, damage to electronics starting as low as 3 kilovolts. Any nuclear bomb we have right now can produce that small amount of voltage. Induced current reaches 3,000 amps. That's the current of 15 homes, used by 15 homes on one CPU. So now moving on to the fifth part. These are simply defense methods that we currently have to defend against a nuclear bomb. But if you think about it, most of these methods can only be used in line of sight. And if you're in line of sight, you can easily take out the nation due to how Compton scattering works, or simply a flow of electrons. At least 55 million affected within the first 4 hours, and that is including backups. The 2003 blackout that I believe affected almost the whole East Coast took out nearly 55 million people's power within the first 4 hours, and that was with backups. So if we have no backups, then it'll be much greater than that. 9, grounding will not provide adequate protection. The geomagnetic currents induced in the Earth itself, also known as our grounding, will take in that current that's induced in the ground through the E3 phase of the pulse. 10, we theoretically would not recover due to the cost of overload damages going beyond our national GDP level, and no one will want to help because we have no funds to pay them with. I titled the high-level EMP and solar flare attenuation system, and that is simply a system that allows for a continuous flow of power despite the current conditions. It only attenuates what goes over the predefined level. Just to tell you how we're working on a real-world situation, say that I'm communicating with a welding factory that works at 5,000 watts, plus or minus 10 watts. The maximum they can have current coming in is around 5,010 watts. So if you reach 5,020, my system will only attenuate 10 watts, bringing it back down to the maximum, keeping the continuous flow of power coming in. My plan will only take 1.5 years to implement, based off of an 8 to 10 hour building cycle. No measurable delay in attenuation response. It's around 600 picoseconds, and that gives the system the chance to attenuate the current flow through the system before it leaves the actual attenuation system. There are no required connection types between quote-unquote dirty and clean connections. A dirty connection is where the surge will come in. A clean connection is the modified or attenuation surge. No added components are needed to add to the total cost. No shunt capacitors, MOVs, resistors, etc. are needed for the system because it's an attenuation system. It's already included with the system. No add-on transient protector or lightning arrestor, as these are created during the construction of the system, as this is an attenuation system. So it'll be exactly the same as a lightning arrestor, but faster. Currently, it's a breakthrough in circuit breaker technology. And what I mean by that is fast response and high level of attenuation makes it far more cost effective than a breaker of the same size and efficiency. The attenuation circuit is activated before the voltage or current bypasses the point of attenuation, and this simply means that the circuit is activated and is attenuated before the pulse has time to reach into the electronics. Encourages predefined power, but blocks out transient voltages. What this means is that it will once again allow 5,000 watts to come in, but if 5,020 watts come in, it will simply attenuate the 10 watts, bring it back down to the predefined level. Effective EMP and solar flare coverage. This system can protect against 200 kilovolts easily and 30,000 amps. Can't be combined with any power system that has a power input. So if you have a transformer, a generator, or a simple power supply, you can protect it, the system. It does not interfere with the output power of the system needing protection. This is the most important. It does not change the current, does not change the voltage or the frequencies of that circuit. It simply provides attenuation when it needs to. Now, there is no worry as to if this will happen. I'm just trying to get started at full speed. I made a few calculations as to how long it would take to implement this plan. Once again, I stated that it would take 8 to 10 hours to build one system with my own hands. With machines, it'll be 10 systems a day. And at this speed of 8 to 10 hours, I could have enough attenuation systems to protect the 300 plus transformers and generators in 5 months. The time it takes to implement will only be another year. So we're looking at a year and a half from production to protection. Now, if you all are 2012 fans, which I don't think you are, that will be May of 2012. So 7 months before December, we have attenuation systems installed. As you see, that was about a second and a half, running at only 30 milliamps and a wire 1 million times the diameter of a wire in the CPU. So if you imagine 3,000 amps in a wire 1 million times smaller, it'll be a few milliseconds. That's a charging circuit running at about 40,000 volts and 30 amps. And that's a small system I made up very quick. As you can see, I can make a system at any rating in a few minutes. Maybe watch that. Rated around 15 volts. Despite the fact that we have 40,000 volts coming in. Another quote from my pastor is that if we fail to prepare now, then we'll spend a lifetime repairing. And that simply means that if we don't have any protection from an EMP, we will never really recover from the damages affected or induced by that. So, thank you for giving me the time to share, and I apologize for going over. But if you have any questions, you can ask them right now if you feel like it.
Great. That's very good.
Okay.